Question 11. We've got an equation here which is 2x squared take away 1. Now personally I'd leave the minus for a minute and just do the 0 and the 2. Well, 0 is easy because 0 squared is none and 1 on times 2 is none again, so that'll just be minus 1. Remember, you've got to square first then times by 2. Some students will times by 2 and square, and that's where they'll get this one wrong. So it's 2 squared, and look at it's 2 and 2 anyway, so that'll be nice. 2 squared is 4, times 2 is 8, 8 take away 1, 7. Your minus 1 then, minus 1 squared is 1, times by 2 is 2, take away 1 is 1. So we've got the values there. We've got to plot the values then. So minus 2, 7, sorry, 2 minus 7, minus 1, 1, 0 minus 1, 1, 1, and 2, 7. Then plot these values in, curving through and then coming up. Now my curve's awful, you'll draw a much better curve than that. And then it says use your curve to write an estimate of solutions for this equation here, but equal to 0. Well, it's changed from y equals to 0 equals. So if y equals 0 then, we're actually looking at these values here. So those 2 points there. So by my estimation I'm going to say that x equals roughly minus 0.8 and 0.8. Now they're giving you a range from 0.6 to 0.8 and a minus and a plus there. Question 12. An object is travelling at this meters per second. How many seconds will it take to travel this distance? Use your answer in standard form. So what we're doing is we know the total distance. So we know it's travelling that far. So we're going to divide that then by the speed, because that will tell us then how many seconds it's going to take in total. Now you can use the middle bottom button, so you could press 3.45, then press the middle bottom button, press 10, and then divide that by 2,650. Now that will give you this long number here. Now correct the two significant figures. So significant figures are here, the first and the second one. So it's 1.3 times 10, and then we've got to move it once to get it 13, 2, 3, 4, 5, 6, 7. So it's going to have to move 7 times. Question 13a. You're given the fact that y is directly proportional to x. So y is directly proportional fish sine to x. When x is 600, y is 100. Find the formula of y in terms of x. So we put y equals kx, the constant of proportionality here. Y is 10 and x is 600. So if we divide by 600, that then gives us k. So 10 divided by 600 will then give you 0.016, and the 6 is recurring. So then we put that back into here. You can also express that as 1 over 60 if you like. So we then get y equals 0.016 recurring x. So instead of the k, we put that. Part B then. Calculate the value of y when x equals 540. So y then equals 0.016 recurring times by 540, which will then give you 9 as your answer there. Question 14. Sorry, I'm wrong there. Question 14. Given that x is an integer such that x equals this and y integer this and y equals this, write down the possible values of x. So x can be between minus 2 and minus 2 and 3, and can include 3. So for 14a, it can't include minus 2, so it could be minus 1, 0, 1, 2, or 3. On the grid below, show this region. So y is greater than 1. So the y value here, this is 1 here, so it's greater than 1. Now it can't be equal to 1, so use a dotted line to show that it can't equal 1. It's going to be above this line. Pick another one that's easy, the fourth one. X is greater than 0, so X is here. 0 is there, so greater than 0 is this line here. The other two require a bit of thinking about. First of all, got y equals 2x minus 2, but then I'm going to put the inequality sign less than. So what I do here then is just create a little table of values. So use 0, 1 and 2. If x is 0, y is going to be minus 2. If x is 1, 2 times 1 is 2, 2 take 2 is 0. And x is 2, 2 times 2 is 4, take away 2 is 2. So if I plot these values in, we're there. Now it's again a dotted line because it's not saying equal to. So I draw my line up there. Now this one is saying less than. So we'll look at that in a minute. We'll then plot the other value. Imagine it's an equal to sign. X minus x, y less than x minus 6 minus x. So we create a table of values again. X is 0, 1 and 2. Well, if x is 0, y is 6. If x is 1, y is 5. And x is 2, y is 4. So we plot these values. 6 is there. 1 and 5, 2 and 4. So again we draw this in, which is there. So we want y to be less than that also, and greater than 1. So here is the region that we are after. Question 15. Quite a few bits to 15. So 15a I. Write down an expression in terms of a and b for CA. So C to A. Well, how do you get from C to A? Well, you know if that's A there, that's also going to be A. So C to A will just be a double movement of A to A. Part 2. BA, so going from B to A here, well I'm going to go down this way and up this way. So BA will be minus B, and then plus A. Part 3. BC, well BC is here, so that'll be minus B minus A. B part 1. X is the point such that OX is 2A minus B. So what I need to do is I need to draw that roughly. So 2A, so another A up there, and then minus B. So the movement down there is minus B. So that point there is X. Find an expression for A and B for AX. So AX is here. So because I've drawn it, I've made it very easy for me to actually write down what that is. So AX is simply going to be another A and then minus B. And part 2, A, B and X lie in the same straight line. Explain why. So A, B and X lie in the straight line. Why could that be? Well, how would you explain that then? Well, AX, what's that the same as saying? A to X. Well, maybe I could go another way through and explain it through that. So maybe I could say it's going the same as saying going from A to O and then O to X up here. So A to O is minus A, and then we've got O to X. What's O to X going to be? Well, we've already been told and defined that. That's 2A minus B. So if we put all that together, we'll get A minus B there. So what does that then tell us? Well, that's first of all the working out from the previous bit, just sort of bring that together. How on earth are we then going to solve the next part? Well, this is the thing that you sort of pause over, and purposely pausing because you've got to think about it slightly. AX, well, what's AX going to be the same as here? Have we proved anything? AX is the same as BA. Does that help us? Well, AX is the same as BA. So that means that they are parallel. So therefore will be the same slope. A is on both. A is on AX and BA. So therefore you're proving it, because if A is on the same and they're both parallel, then they've got to be on the same line. So therefore A, B and X are on a straight line.